In this task, we will discuss the different requirements of LangChain as well as the various models it provides access to. Regarding requirements, the only thing we need is an API key for our large language model. In recent months, we have been working with the LangChain model, and we have recently witnessed the emergence of a multitude of large language models where different developers or companies have developed their own models. Initially, the most well-known model was ChatGPT, but now various companies have also developed their own models, such as Llama, Bloom, or GPT. As users, we have the option to choose between proprietary large language models, which require an API key, usually paid, or open-source models, depending on the trade-off between performance and cost that we want to achieve. On one hand, we have proprietary language models, which are closed-source and owned by different companies, developed by experts. Generally, they are larger than open-source models and therefore offer better performance. However, it's important to note that their APIs come with a cost. Some examples of well-known proprietary models would be those from OpenAI, but there are also models from Kojira, AI21, OLAPS, or Anthropic. On the other hand, open-source models tend to be smaller and have fewer capabilities compared to proprietary models, but they are more cost-effective, and most of them are completely free. Some examples of open-source models would be Bloom, developed by VG Science, Llama, developed by Meta, Flanty5, developed by Google, and GPTJ, developed by Aluther AI. As we can see, we have the option to choose from different types of large language models based on whether we need more performance, in which case proprietary models are preferable, or if we require lower costs, in which case we can turn to open-source models. It is recommended to explore the Hugging Face website, a platform where various open-source models are published, providing access to different models. As we already know, there is a wide variety of large language models available, and LangChain offers integrations for many of them. Additionally, it provides a simplified interface to connect with the different models. In LangChain, we differentiate three types of models based on their input and output types. First, we have the conventional large language models, such as ChatGPT, which take a text string as input, the user's prompt, and generate a text string as output. Next, we have chat models, which are similar to the previous ones, but instead of a single text string, they take a list of chat messages as input and return a chat message as output. In other words, the input for these chat models would be a conversation rather than a single input text. We have the embedding models available as well. These models take text as input and return a list of numerical values, known as embeddings. These embeddings are the numerical representation of the input text. These numerical representations help extract information from the text, which can then be used to calculate similarities between texts or generate summaries. Another example of their use is when they receive text as input, but unlike other models, embedding models do not provide a text output. Instead, they offer a numerical representation of the input text. As mentioned before, this representation can be used to assess similarity between different input texts. To get a better understanding of how these different types of models work, it is recommended to review the LangChain documentation, specifically the Models section, where you will find relevant information. In that documentation, there is a section called Getting Started that provides practical examples. We mentioned that there are essentially two types of models, conventional models and embedding models. Within conventional models, we have the standard large language models, LLMs, and chat models. How do they work with LangChain? First, it is necessary to import the corresponding libraries, just as you would normally do in Python with any other library you're using. You would use the OpenAI class for conventional models or the ChatOpenAI class for chat models. The process is as simple as invoking the imported model and using the predict function, passing it the prompt. For example, if the instruction is for the chatbot to say hello, the chat response will be exactly that, hello. For the chat model, the procedure is similar. You use the chatModel.predict function and pass it the input text. As you can see, the usage of these models is quite straightforward. Additionally, we have the option to add messages, as in this case, using the human message function. This function is very similar to the one described earlier, and by using it, we obtain the chatbot's response. Regarding the models, we mentioned that we have three types: conventional LLMs, chat models, and embeddings. You can access each of these sections in the Getting Started section to learn how each of them works. For example, let's consider the chat models, which are very similar to the previous ones. First, we import the function, which in this case is chat-OpenAI, and then we directly pass the input text. In this example, we are passing different concatenated messages to ask it to translate a phrase. Later on, we pass the phrase "I love programming." We can proceed this way or chain different messages for the chat, which is done as follows. First, we introduce the system message, which is a kind of message to the system indicating what the chatbot should do. All of this is explained in detail in the documentation. As we mentioned, it allows us to concatenate different messages and then obtain the result. If you have any doubts about the different model types, simply refer to the Models section in the Longshine documentation.